أشرف المرسلين نبينا محمد وعلى آله وصحبه أجمعين. نرحب بالحضور الكرام المنضمة لهذا البث. ملتقى علم البيانات يأتيكم اليوم من جنوب غرب المملكة، وتحديدا من منطقة الباحة. مش نسمعوا فيديو مدته 3 دقائق وبعدين نرجع للندوة.
Hello, my name is Flora Huang, and I'm my name is Flora Huang, and I'm Hello, we are Women in Data Science. Women in Data Science.
I became a WITS ambassador because I dream of an equitable world. Because I dream of empowered women help humanity make better decisions. Help humanity make better decisions.
As a woman,
data science.
I'm hoping more women. I'm motivated to join this exciting field.
The WITS community has really my sense of purpose in these life goals. My sense of purpose in these life goals, my confidence in such a meaningful way to be able to support others.
The most rewarding and impactful aspect about my work as a clinical data scientist is to use the data generated by doctors, nurses, and the healthcare system to improve the care of future patients.
I'm delighted to bring this event to Pakistan, along with so many WITS ambassadors worldwide, so that we can inspire the young girls of data science.
The use of data science to address data science sustainability issues continues to inspire me in my data science journey.
Through WITS Alexandria, I've got the chance to meet with brilliant female professors, learn about the research, and bring that to my community as well.
I'm a WITS ambassador because I wanted to inspire more young girls like me to join the field of data science, and I believe that in the future there must be more women in this field.
I'm really excited to continue bringing WITS events to my school and schools across Australia to empower girls to get involved in the field.
It's great that we've got women in data science events, and know that there's so many more inspiring stories as part of the Women in Data Science journey.
Hi, I'm Carolyn Bertozzi, and I am a chemist who works in the area of drug discovery. I've had many opportunities in my life to collaborate with data scientists. They've been absolutely central to the work that we do. We couldn't have made the discoveries that we've made without having people to analyze very large data sets and to help us find hidden trends within them. Now, when I was growing up, I was somewhat insulated from the idea that women or girls couldn't be scientists because I came from a family of scientists. And when I was in college, I learned that not everyone had that privilege. I hope that all of you women data scientists or aspiring data scientists will truly feel that you belong in the field, because I believe it, and your participation is absolutely essential for us to bring the full benefits of data science to solve the big problems in humanity. So just as I was so fortunate to have a family that created an environment where I could believe in myself as a scientist, I'm hoping that you all have the confidence to pursue your dreams and that you help the generation that follows you in the same way that hopefully someone of my generation can be of help to you. Good luck with all of your work.
مرحبا بكم مرة أخرى. الندوة هذه بعنوان NoSQL Database. اخترنا لكم هذا المجال بالتحديد نظرا لأنها نوشن جديدة وأصبحت تحتل مكانة كبيرة في السوق نظرا للإكسبلوجن متاع الداتا ولا البيك داتا. معكم الدكتورة سونيا سعيد اللجمي، سفيرة علم البيانات لجامعة ستانفورد لمنطقة الباحة، أستاذ مساعد في تقنية المعلومات ومشرفة قسم تقنية المعلومات بكلية علوم الحاسب لجامعة الباحة. أيضا أنا باحثة بمخبر بحثي ميراكل بتونس، ومجالي البحثي الرئيسي هو الانوتيشن of the multimedia document، وقد قمت بالإشراف أو المشاركة في الإشراف على رسائل ماجستير ودكتوراه وقد كنت عضواً في عدة لجان تقييم أوراق علمية. أشكر الرعاة والمنظمين، كما أشكر الشريك الاستراتيجي. نبدأ بإذن الله بمداخلة أولى من قبلي بعنوان NoSQL Database, the Basic Concept and Challenge. ثم تليها مداخلة ثانية تقوم بها زميلتي العزيزة الدكتورة أحلام النابلي، أستاذ مشارك في نظم المعلومات بكلية علوم الحاسب وتقنية المعلومات بجامعة الباحة. So for my agenda, I will start my talk by presenting the context. After that, I will present the NoSQL database, the basic concept or the type and the type of NoSQL database. And I will finish my talk using by the challenge of NoSQL database. We are in the context of big data, which get bigger every day, and the need of use more and more cloud technology and distributed data storage and so on. So thanks to the internet, social media like Facebook, Twitter, and so on, the mobile devices, the massive volume of varied and unstructured data, as you can see in the chart, are bombarding the network. The chart shows here the data generation every minute. So this explosion of data is not suitable for a relational database. And for organization, a new kind of database has emerged known as the NoSQL database. So كما تشوفوا الأرقام نقدر نقارنوا مكانة NoSQL database. There are essentially here in the graph the key value, the document-oriented, the column-oriented, and the graph-based. They are the most known. So this first graph represents the current database ecosystem and the market share of the various type of database in 2023. As you can see, relational database is still the most used type of database despite all the hype around NoSQL database. لكن إذا نقارنوا الجراف in 2021 نشوف إنه الريليشنال database خسرت تقريباً 20% من السوق في سنتين. So this chart also shows the trend of the last 2 years. It shows that the NoSQL database gain adoption with the developer. In fact, for example, in the use of a graph based database is increasing exponentially. كما تشوفوا هون في الجراف. Coming to the basic concept of NoSQL database. So here, where did NoSQL originate? So the first who used the term NoSQL is Carlos Trozzi in 1998. To name his lightweight open source relational database that don't expose the standard SQL interface. After, in 2009, the same term is used by Eric Evan in the actual meaning. That is non-relational, distributed, and not conform to a side property. So NoSQL, also called not only SQL, it facilitates the storage and retrieval of data in a non-relational database format. Unlike the relational database, NoSQL don't require a fixed schema. It has a dynamic schema. It not use the concept of join That is mean the complex query is resolved in the programming level and not in the query language. Also, allow relaxation for one or more aside property and use the cap theorem. So what is aside property? In fact, SQL database typically follow aside property regarding transaction. So aside stands for atomicity, consistency, isolation, and durability. For the atomicity, it means that the entire transaction takes place at once or doesn't happen at all. So if each data transaction is not properly carried out, then the process returns the final state. For the consistency, you ensure that the processed transaction of data does not damage the database structural integrity. For the isolation, multiple transactions occur independently without interference. For the durability, means that the data related to the processed transaction will not impact the manipulated data even a transaction fail. As we can observe, the aside model ensures that a transaction is reliable and consistent. So the SQL database fitting this model is the best solution for organizations and businesses that cannot risk invalid and interrupted data transaction or any other error, like financial institution, for example. On the other hand, for NoSQL database, the priority tend to focus on flexibility and on a high transaction rates. For this reason, the base model or the cap theorem is followed in many NoSQL database systems. So it stands for consistency. It's the weak consistency here. That means all clients see the same data at the same time. The availability, that means the system continue to operate even the presence of node failure. And the partition tolerance, that is mean the system continue to operate in spite of network failure. So usually in the NoSQL database, you scale out. You have to partition that leave either consistency or availability. You should, in this case, shows availability over consistency in almost all cases. Here we present some SQL and NoSQL database system. In SQL, you can see the classic one, like Oracle, MySQL, SQL Server, SQLite, and so on. For NoSQL management system, there is several. Each one is specific for one or two types of NoSQL database. For example, Redis is specific for key value. Cassandra is for columnar database, and MongoDB for document-oriented. Coming to the architecture of NoSQL, most of the system use the distributed architecture, like master-slave, master-master, masterless, and so on. In fact, this architecture follow the scaling out or horizontal scaling. That means that you use other machine to extend resources. This machine can work in parallel. So the scale out have the advantage of, in case of failure of server, you can easily replace it or tolerate. By opposition of this approach or of this strategy, you have the scaling up. Or scaling up, that is mean, or vertical scaling, also call it, is adding more resources like CPU, memory, or disk to increase more compute power and storage capability. So the scaling up is followed by SQL database. Some type like the key value database follow the distributed architecture, specifically the DHT, or distributed hash table. So for the DHT, it allows the partition of data, here the key value, across many machines. So ساعة احنا نحكيو على NoSQL database ولكن لم نعرض أنواعها بالتحديد. The well-known NoSQL database are the column-based, the most popular system are Cassandra or Hashbase and so on. The graph-based, the most popular system are Neo4j, OrientDB or ArangoDB. The key value database, there is the most popular system are Redis, React, or Mongo, or Amazon DynamoDB, and the document-oriented database. And the most popular DBMS are MongoDB, CoachDB, RavenDB. So coming to the first NoSQL database is the column-based. So the column-oriented database or the columnar database is also non-relational database that store the data in column instead of row. So it's designed to read data more efficiently and retrieve the data with greater speed. So it is used to store a large amount of data. So the key feature of this kind, or of this type of NoSQL database is the scalability, the compression, and it is very responsive. The main concept of the data model of columnar database are the column family, the row, and the column. So the column family is a collection of similar rows, not necessarily identical. The row is the collection of columns. This row is associated with the unique row key. The notion of column consists of column name and column value. As you can see in the example, the notion of column family is like grouping column of data with the same table. For each column family consists of one or more columns. The notion of column is not like a SQL database. It consists of column name and column value. Here is the Hbase, or Hbase is a system based on a columnar database. Here is the Hbase logical view. As you can see, we represent the row key in similar to the notion of a primary key. Each row key refers to minimum one column family, and each column family contains minimum one column. We can have the same data, that means the column name. For this example, Hadoop, okay, with different, as you can see, with different column value and the different timestamp. So mapping to the physical model in Hbase, each column family is stored in a separated file. The row key is split to all columns. As you can see, the same column can have different cell value. Each column, each value is saved with different timestamp. So here we present an example of a comment Hbase. To put data in the table, for example, you use the put command. Here in this example, we insert the three values. One at a time, three operation. The first insert is at row 1, column CFA, with a value of value 1. Column in Hbase are comprised of a column family prefix, CF in our example, followed by a column and then a column qualifier suffix A in this case. Coming to the next type, the key value store. It is the simplest form of NoSQL database. So every data element is stored in key value pair. The data can be retrieved by using key allocated to each element in the database. The value can be simple data type like string or number, or complex like list, set, or hash, and so on. The key feature of key value store is the simplicity, the scalability, and the speed. So most social media networks are based on this store, like like Facebook with the DBMS named ZPDB, or Twitter with DBMS named Manhattan. Here we present a real example of key value store. So the name of the page can be its key, and the HTML code can be a string value. We can consider a key as user logged in today, and the value represented by a set of user, or a list representing the ID of last post. Here the order is important. We can consider also a value as a hash table with presented itself in form of key value, or a scored set, like this example. The difference with the set is that for each element in the set, we associated a score. You can see in the example of Redis comment, here several examples of Redis comment. The commands are very simple, as you can see. And as the other system in NoSQL database, the language depends on the DBMS. So no join, no complex query. The command depends on the type of the value. For example, to make an insert operation with string value, you use a set operation. For a list value, you can use the push operation. So R push to insert in the right and L push to insert in the left. And for hash value, you use for the same operation hash set. For set value, you use sadd. And for a sorted set, you use zadd. Coming to the third type of document of NoSQL database, it's document-based database. So this type gained a lot of success due to its simplicity. The idea behind is instead of storing data in row and column as SQL database, we use the document to store the data. The key features are: we have a flexible schema, faster creation and maintenance, and no foreign key. The data model is around the document. It is called self-describing. That is mean the field name have a semantic, as you can see in the example. The document have hierarchical tree structure. It can be JSON or XML. For MongoDB, it is JSON. Each document have unique identifier allocated by MongoDB. A group of document is called collection. As you can see in the example, a document can have a field name and a field value. You have a field name and a field value. The value can be scalar, can be like int, like Boolean, string, date, and other. The value also can be a document or nesting, we call nesting or embedded document, or an array of scalar or embedded documents. In the example, you can see that a document represents, this document represents a row in SQL. And instead of presented foreign key to link to the other table, we nest here, we nest the whole document, the whole row in the same document. For the MongoDB query language, it's include all the CRUD operation. The syntax is very simple. The create is based on insert, save, or update operation with the upsert option. Retrieving document can be according to complex query condition with find or find one. You can express the query and a projection. The update is done using update operation, and the delete can be done with the remove operation with just one option if you want to delete one document. For example, a delete operation expressed in SQL language is as follows. It is expressed more simply in MongoDB using the instruction db to refer to the database, users to refer to the collection, and the remove to refer to the operation, and the criteria or the remove criteria status equal to T. The last type of the graph-based database, it focuses on the relationship between the element. It stores the data in the form of node in the database. The connection between nodes are called link or relationship. The key feature of this kind or this type of NoSQL database that is, it is easy to identify relationship between data by using the link, and you have the queries output in real-time result, and the speed depends upon the number of relationships among the database elements. The property graph model in Neo4j, so Neo4j, it's well-known DBMS system, graph-based NoSQL system, are node relationship and the property and label. So the node represents the object in the graph. It can be labeled. Relate node, the relationship relate node by type and direction. The property, it's a pair of name value pair that can go on node and relationship, and the label group node by row. We can see in the example 3 relationship between 2 nodes labeled person. This relationship has a direction and a type, here married to and no. We have also property can be assigned to a relationship, like the relationship drives. The property is since 10 January 2011. And the property can be also assigned to node, like the name, the when he is born, etc. So the cipher is the query language associated to Neo4j. For example, an operation create can be to create a mini graph like this one, Omar no Amal. We just express like this query, create P1 person with the name Omar, no is a relationship, P2 person, name Amal, return P1 R and P2, where P1 R, P2 are alias or variable, person is the label of the node, and the property assigned to the node, name Omar and name Amal. The same operation can be replaced by merge to create or retrieve this subgraph. If we want to retrieve something from the graph, We use match. So the match operation can be expressed like following: match P1 person, name Omar, know whom, return whom. So this query is expressed to find the person which have a relationship known with the person Omar. We cover all the most known type of NoSQL, coming now to the challenge of NoSQL database. So before deciding when to use NoSQL, it is essential to consider the following aspect: the type of data in question, the amount of data, how will the database be managed. In fact, NoSQL databases are able to store various types of data and do not need to be structured as SQL database. So non-relational database allow for great adaptability and flexibility, making it a more suitable choice when handling large set of unstructured and unrelated data. Also, the non-relational database tend to excel at scalability and availability requirements, being ideal for social network and real-time application. So if you have online gaming, for example, or instant messaging, for example, NoSQL will be your ideal solution. So when data is highly structured and require complex querying, NoSQL not will be your ideal solution. Because if you, as I presented in the past, the query language for NoSQL database are very simple and not expressive to write complex query. So if you have a complex query, you must make it in the programming level. So as also I presented before, when data consistency is critical, you can't use NoSQL. In the case of finance application or banking application or health application, and when transaction need to a site compliant. So to recap, the challenge of NoSQL is the lack of standardization. So in fact, each DBMS has its own query language and has each type have its own data model, which make it difficult to migrate data from one database to another. The second point concerns the limited querying capability. So NoSQL database is designed for high scalability and performance, but they often lack the advanced query capability and the traditional SQL database. So here the complex query is difficult, as we said before. Data consistency. NoSQL database often sacrifice data consistency for scalability and performance, which can lead to data inconsistency in certain situations. So you are in the domain in the banking or finance, NoSQL can't be adopted. Also, they suffer of the limited community support, as NoSQL database is relatively new compared to traditional SQL database. So here is less community support and fewer resources available for problem solving. It also suffers of security concern. So it's often more vulnerable to security breach than traditional SQL database due to their distributed nature and lack of standardization. And finally, the complexity. It can be more complex to set up and maintain than traditional SQL database due to their distributed nature also and the lack of standardization. Thank you for your attention. Don't hesitate to ask any question. I wait. There is any question? So if there is not if there is not a question, I can نمر الآن إلى المداخلة الثانية حول big challenge in NoSQL data warehousing تقدمها الدكتورة أحلام أستاذ مساعد بكلية علوم الحاسب وتقنية المعلومات بجامعة الباحة. تفضل دكتورة.
السلام عليكم ورحمة الله وبركاته. مساءكم جميل. سعيدة اليوم بوجودي بينكم في هذا الملتقى العلمي. أشكر الرعاة والمنظمين على هذا الملتقى الرائع والرائد في مجال علم البيانات. كما أشكر الدكتورة سونيا سعيد اللجمي سفيرة علم البيانات لجامعة ستانفورد لمنطقة الباحة لإتاحة هذه الفرصة لتقديم هذه المداخلة. معكم الدكتورة أحلام التهامي النابلي، أستاذ مساعد بقسم نظم المعلومات الحاسوبية ومشرفة قسم بكلية علوم الحاسب وتقنية المعلومات. أيضا أنا باحثة في مخبر البحث ميراكل في مجال الديسيجنال سيستم وبالتحديد في الداتا ويرهاوس فيلد. قمت أيضا بالإشراف على العديد من رسائل الماجستير والدكتوراه، وأيضا كنت عضوة في عديد من لجان تقييم الأوراق العلمية. Let's start my talk entitled Big Challenges and NoSQL Data Warehouse. In this talk, I will start by giving the context of this presentation. Then I will concentrate on the basic concept of data warehousing. Finally, I will present the main challenges in NoSQL Data Warehouse. Nowadays, as said Dr. Sonia, the data available, or the available data that can be used to create a data warehouse are generated from big data. Big data is a combination of structured, semi-structured, and unstructured data collected by organization. Social media, as a part of big data, are information sharing platform which are highly valued by everyone these days and makes it easy to communicate, share documents, chat, and even build communities. Indeed, the proliferation of many sites such as Facebook and Twitter leads users to perceive the web as a place to exchange ideas and opinions. Note that the majority of data generated from big data are stored in NoSQL database. The most important V's that characterize the big data are the volume, the variety, the velocity, the veracity, and the value. The first one, the volume of data has expanded exponentially over the last few years. For the second V that characterizes the big data is the variety of data. The variety of data, so the data which is generated by the big data can be images, videos, chat, posts, and so on. For the third characteristic of V, which is the velocity of data, time is an important factor when accessing big data as a new information emerges through the day. For the first V, which is the veracity of data, big data contains a large quantity and ambiguous and dirty, that means unverified data, that needs to be cleaned and organized before serving its purpose. The last V, while the other V presents external factors affecting big data, the value presents the internal factors associated with business strategies and execution. So the use of data from big data for a company is almost not a choice, but rather a necessity, from where it emerges as a new tool at the service of the company, which allows them to manage their image, to develop financially, and to enrich their experience on the web of the market. So in order to take into account information from big data, several decision makers have thought about ways to capture and take advantage of this information. Thus, the establishment of an adequate decision-making process has become a strategic need. Let's now present the concept of data warehousing. The data warehousing is used in many applications like banking, insurance, manufacturing, healthcare, education. As shown in this chart, the market of data warehousing is still increasing and is expected to grow on account of the rising volume of structured and unstructured data, the emergence of various innovation techniques such as artificial intelligence, cloud, and Internet of Things, among others, is anticipated to offer a huge growth opportunity for this service. So a data warehouse can be defined like a relational database designed for analytical needs. The data warehouse is basically based on the online analytical processing, which is a multidimensional data model. Here I will present a brief history about the concept of data warehousing. As data began to proliferate in the 1970s, organizations needed a way to store and access all their information. The computer scientist Bill Edmond, the father of the data warehousing, began to define the concept in 1970s and is credited with coining the term data warehousing. He's published his book, Building the Data Warehouse. وفعلا ينسب إليه الفضل في صياغة مصطلح مستودع البيانات الذي تم الإشادة به كمصدر أساسي في تقنية تخزين البيانات. Also, we have the Ralph Kimball, which is another technology expert who published the Data Warehouse Toolkit in the mid of 19th, took a slightly different view of data warehousing concept regards to Bill Edmond. So, The data warehouse is a central repository of data extracted from disparate sources. These sources can be transactional systems, operational data sources, or external data sources. As against database that stores current data to turn an application, the data warehouse integrates historical data with real-time feeds to enable businesses reporting and data analysis. So data warehouse is a repository for historical, integrated, and consistent data. It is equipped with tools that offer company management the opportunity to extract reliable information to be used for the decision-making process. So the data warehouse involves processes that extract data from different and available data sources, integrate the extracted data, remove any flaws and inconsistency from the extracted data. Then this data must be stored into a data warehouse. The last process which is involved in data warehousing, it provides end user with access to the data so that they can carry out complex data analysis and prediction queries. So let's know why data warehouse is important. First of all, data warehousing is one of the core processes in business analysis reporting. Data warehouse data is easily available for on-demand use, for review and analysis, which allows businesses to make informed decisions. Also, data warehouses are vital because they integrate and store in a central database and in a standard format all the valuable data used for enterprise decisioning. In turn, organization can avoid the unpredictable result of taking an ad hoc approach to data access and integration. So data warehouse maintain historical data record. This data can be stored by day, by month, or by year. Data warehouse keep data secure by storing it in a single location where only those who need a specific data are granted access to it. Data warehouse provide easy access to a high quality data, which enable faster, more informed business decisions. And finally, make big data available for basic reporting as well as for advanced analytics like machine learning and natural language processing. As defined by Bill Inman, data warehouse is based on a set of properties which are subject-oriented, integrated, time-variant, and non-volatile. What means subject-oriented? That means the data warehouse is organized around the major subject such as customer, product, sales, focusing on the modeling and the analysis of data for decision maker and not on daily operations or transaction processing. The second property is integrated. That means the data warehouse is constructed by integrating multiple heterogeneous data sources. These data sources can be relational database, flat files, online transaction records. In this step, data cleaning and data integration technique are applied. For the third property, which is time variance, the time horizon for the data warehouse is significantly longer than the operational system. In the operational database, we store the current value of data. But in the data warehouse, we provide an information from an historical perspective that can be we can save the value from 5 to 10 years. For the last property, which is non-volatile, in the data warehouse, two operations only are required, which are the loading of data and the access of data. Let's now present the main architecture of data warehouse. It is composed of 4 layers, which are data source layer, staging area layer, data store layer, and the analytics layer. The data warehouse is based mainly on the ETL process. Let's now explain the data source layer. It has all the data source of the company that feed data into the data warehouse. For instance, various application databases and devices collect your business data. For the second layer, which is the staging area, the data from data source layer doesn't directly enter to the storage space. It needs to be cleaned and processed. If your data warehouse design allows data transformation within the targeted database, which could be your data warehouse or your data mart, then the staging area can be absent. For the third layer, which is considered with the storage space, it represents the permanent and the master database within the data warehouse that stores your business data in a structured format. The data storage contains the data warehouse and the data marts. The last layer is concerned with the analytics and the business intelligence layer. Many tools can be used in this layer, like data mining tools, OLAP tools, visualization tools, that helps in querying the data in the data mart or in the data warehouse. Let's now present the main process of data warehousing with the ETL process. ETL is the abbreviation of extract, transform, and load. First, data must be extracted. So we get data from multiple heterogeneous and external sources. This data then must be cleaned. So we detect error in the data and rectify them when possible. After that, the data must be transformed. We convert data from legacy and host format to warehouse format. And finally, this data must be sorted, summarized, consolidated, and loaded to the data warehouse. When we talk about data warehouse, we must talk about the online analytical processing. The online analytical processing is a technology that organizes a large businesses database and supports complex analysis. It can be used to perform complex analytical queries without negatively affecting transactional system. OLAP is a flexible way to make complicated analysis of multidimensional data. Let's now present a comparison between the OLAP and the OLTP. The OLAP means the business data warehouse, and the OLTP means the business process. That means the classical database. OLAP, as we said, it's the online analytical processing. We have slow query. The schema in the OLAP are denormalized, and we store historical data. But in the OLAP system, it is dedicated for transactional system. We have a fast processing, the database are normalized, and we store current data. So we can say that the OLTP is for running the business, and the OLAP is for analyzing the business. So since we have presented the main concept of data warehousing, let's now discuss the main challenges of NoSQL data warehouse. Big data places new demands on data warehousing system, starting from the design, passing by the ETL process, finishing by querying. Thus, the designer is faced to many challenges. As presented in previous, the big data imposes many challenges in terms of the large volume. For example, Facebook exceeded 3 billion users in October 2021. The second one is the rapid growth of the mass of information. Every day, more than 1 billion of hours of video are watched on YouTube, for example. Third, the emergence of semi-structured and unstructured data. Really, more than 80% of the data generated on the web is unstructured. So, conventional data warehouse solution or approaches are mainly based on relational database, which are unsuitable for unstructured data generated from big data. In addition, the design of data warehouse, we use a fixed schema, which are completely managed by the designer, while data from big data are characterized by schema-free with a large volume and velocity of data. In the next slide, I will present the first challenge. The challenge in creating a data warehouse from NoSQL database lies in the fact that NoSQL databases are designed to handle unstructured and semi-structured data, while data warehouses are designed to handle structured data. That means the data in NoSQL database may not fit the predefined schema of the data warehouse, making it difficult to extract and transform data for analysis. In more details, for example, in the design process, faced to the volume and the velocity of data generated from big data, the designer is faced with the problem of identifying multidimensional concepts in order to identify the schema of the data warehouse. That means which data are important to use in analysis. To overcome this problem, some researchers have used the data mining techniques. As example, we can see the clustering techniques is used to enrich automatically an existing data warehouse schema. As the second challenge in NoSQL data warehouse, another challenge is that NoSQL database often have different data models and query language, which can make it difficult to integrate them into a single data warehouse or to create a data warehouse under a different model. For example, MongoDB uses a document-based model, Cassandra uses the column-oriented model, and the Neo4j uses the graph-based model. This requires additional efforts to map the different model and the query language into a common format. So, in this challenge, many works have done that propose to transform a conceptual model to a logical model based on several NoSQL databases, like the document-based model, column-based model, or graph-based model. These transformations are based on the characteristic of the column-oriented database. As said Dr. Sonia, the column-based model is composed of key space, and each key space is of a column of family or a super column family. Columns and super column. These concepts are used to propose the mapping between models. In this example, we have used only the notion of column family and columns. As a second proposal, we have used a super column family and a column family. By the same semantic, we use the document-based model. As presented previously, a document-based model is composed of a collection of documents. Each collection is composed of document, and each document is composed of attribute or aggregated document. Using the same context, these concepts are used to present a mapping between the conceptual model to the logical model. We have used in this example only the notion of document and attribute. As a second proposal, we have used the notion of embedded or imbricated documents. As we have seen, there is many solutions or alternatives that can be used to create a data warehouse under NoSQL database. But to the best of our knowledge, based on the most important research in this field, there is no clear idea which one is more adequate for analysis. As a third challenge in the context of NoSQL data warehouse, NoSQL databases are often used for real-time application, where data is constantly changing. This means that the process of extracting and transforming data for analysis needs to be done in near real time, which can be challenging for a large data set. Also, data warehouse continue to evolve as industries change to accommodate more cloud computing and real-time data analytics. One data storage repository that it is similar to a data warehouse is known by a data lake. Overall, creating a data warehouse under or from NoSQL database require a careful planning and consideration of the unique characteristic of each database. It might also require additional tools and technology to extract, transform, and load data into a structured format suitable for analysis. Thank you for your attention. I hope that I have presented an interesting talk. If there is any question, you are welcome.
يعطيك الصحة دكتورة أحلام. هل في أسئلة على مداخلة دكتورة أحلام؟ دكتورة وإذا ما في أسئلة لازم راح أختم اللقاء الملتقى. يسعدنا أن نختم ملتقى علم البيانات المتخصص في قواعد البيانات NoSQL واستخدامها في مستودعات البيانات بكلمة شكر وامتنان لجميع المشاركين والحضور الكرام. كان هذا الملتقى فرصة رائعة للتعرف على أحدث التطورات في مجال قواعد البيانات NoSQL والتفاعل مع خبراء هذا المجال. نأمل أن يكون هذا الملتقى قد أضاف قيمة حقيقية لجميع الحضور وأن يساهم في تطوير مهاراتهم وزيادة معرفتهم بأحدث التقنيات في هذا المجال. نشكر جميع الشركاء والرعاة الذين ساهموا في إنجاح هذا الملتقى ونأمل أن نستطيع تكرار هذه التجربة في المستقبل. وقد تحدثنا عن أحدث التطورات في قواعد البيانات NoSQL وعن كيفية استخدامها لإدارة البيانات بشكل فعال وسريع. كما تطرقنا إلى التحديات التي يواجهها علم البيانات في هذا الصدد وكيفية التغلب عليها. في الختام، نؤكد على أهمية دور علم البيانات في تحسين جودة حياتنا وزيادة كفاءة عملية صنع القرار، وسوف نستمر في دعم هذا المجال وتنظيم فعاليات مماثلة في المستقبل إن شاء الله. شكرا لكم جميعا.